Welcome to Shoreside, the Coastal Resilience Podcast and the most resilient podcast in the world. Funded by the Department of Homeland Security, broadcasting out of beautiful Chapel Hill, North Carolina, we speak with the undisputed experts in coastal resilience. Bruce Rosenblum back with you. So wonderful to be with you again. First episode of the new year. And of course, it's going to be a great one despite these frigid temperatures outside the studio. Hope you're staying warm out there. But if you really want to see something hot, do yourself a favor. Check out the new video that we dropped on the special Champ system. This thing blowing up across New England, next-gen storm modeling that has never existed before. It really does not get more cutting edge than this. Link in the description. Find out what all the key players in this space are talking about. And speaking of key players, we actually have one of them joining us today. Thrilled to be having such a tremendous guest on the show today. This brilliant engineer turned professor turned director is a total rock star in the realm of structural integrity. He's given TED Talks on how to make buildings survive the worst storms. And on top of that, he's also appeared on the most watched primetime science show on American TV. Introducing Dr. John Van der Lindt. Doctor, I'm so happy that we could finally sit down together. Thank you for coming on the show today.
Thanks, Bruce. It's great to be here and to look forward to sharing some information with the audience.
I've been looking forward to this for a long time, and we finally made it happen. Thank you so much. You have been very busy from what my sources are saying. Tell me, what types of black box projects had you traveling so much over the past few weeks?
So the last few weeks, actually, it's been testing out in San Diego, full-scale shake table testing, some of the world's largest buildings. These are full-scale 10-story building led by a former student and a 6-story building led by a close colleague. I'm a co-investigator on both those, and these are mass timber buildings to make the world more resilient and sustainable.
Now, how big are we talking about here? 2 stories, 3 stories?
These are, so the one right now is 6 stories, so it's about 65 feet tall. And then the 10-story was 112 feet tall. So these are full scale, weighing on the order of 1 million pounds and sometimes more for the 10-story. And they're tested on the largest earthquake shake table in the U.S. And it's the largest outdoor shake table at UC San Diego in the world. And this is what's called a shared use facility. So the shared use facility, we write a proposal to the federal government. We get funds to test there, and then the shake table time's included because otherwise it'd be almost unattainable. These facilities are so expensive to run.
Now, you mentioned the largest shake table in the U.S. Now, there's a Far East connection here, and it coincides with one of the largest milestones in structural testing history, and you know about it. Tell us about what went down July 2009 in Miyuki, Japan.
So, that's a great question. And so in 2009, we validated a design approach that we had spent about 4 years developing, and we tested at the world's largest shake table in Miyuki, Japan. And so that shake table, it was developed, it was funded by the Japanese government following the 1995 Kobe earthquake. And they, at the time, these are 2001 dollars. They spent $400 million building this facility. And so, we were fortunate enough, again, shared use facility. We wrote a proposal with the U.S. government, and then we collaborated with some researchers out of the University of Tokyo, Shinshu University, a colleague that's now at Kyoto University. And we built a full scale, very, very, large footprint, a 40 by 60 foot building that was 6 full stories tall, and it performed great. And then those things essentially impact building codes moving forward. It impacts the way that people think of wood frame and mass timber research. And so we were really fortunate to be able to do that almost 15 years ago now.
What was the biggest takeaway from that? Because this has never been done before, correct?
Yeah, nothing like that had been done before. In fact, there really weren't these shake tables of this size were just coming into being. Just several of them about 2004, about simultaneously in Japan and the U.S. And so it wasn't really even possible. There were some 2-story structures tested, but these were never had the full footprint. It was always thought of as, oh, that's part of a structure, and they were important and they validated, but these are real buildings being tested. And in fact, these are so large. We had two teams of carpenters, one out of Osaka, one out of Kobe, that would drive in to build this over the course of several months, and then it actually was picked up. A colleague at Simpson Strong-Tie, who was a close collaborator, designed a steel moment frame at the base that actually we picked it up with twin 450-ton cranes and then moved it onto the shake table. And so and there's some stuff out there on the web. If you Google it, it pops up on YouTube and some other things. And but the biggest takeaway, I would say, biggest takeaway was that that you can design a wood frame building at 6 stories to resist what we call a maximum credible earthquake. And that's an earthquake that occurs on average every 2,500 years. So these are just massive, massive events. And we subjected it to that, had very little damage, just some drywall cracking, a little bit of spalling, very repairable damage. And so that was the big takeaway. I think some of the other takeaways were validating numerical models. That's sometimes the most important, because a numerical model is a lot less expensive than building a full-scale building. And we have to pay for removal, we have to pay for demolition, we recycle everything we can, and that starts adding up. And so these tests are millions and millions of dollars each.
But it saves a lot of money on the back end. That's the hope, right?
Yeah, absolutely. And I think, a lot of the wood frame research, it was being done quite a bit by Forest Products Lab, by researchers all around the U.S. and the world for many, many decades, since the 1930s and the 1940s, but never at these scales. And so this was really a first opportunity to see all of it come together. And the argument to do these types of tests is really that we understand the pieces and we design at the component level, and then we put it all together and expect it to perform as if the component performed. But when you put it all together, you get this system effect. And that's really what we need to check. And the sum of the parts doesn't always equal the whole.
Now, you mentioned something important. And real quick, I want to dial this in for our listeners. You essentially developed tools and models that predict how waves and earthquakes and other hazards can damage buildings. This is huge because, like you said, so much of our infrastructure relies on this important work. And real quick, I want to drop the name of somebody connected to these tools that you might know, Dr. Dan Cox. What can you tell us about Dr. Dan Cox?
Yeah, so Dan is a longtime collaborator in coastal work that I've done. So I've done earthquakes. I work in all hazards. I've done tornadoes, earthquakes, tsunamis, as well as hurricane work. And so back after Hurricane Katrina in 2005, I led an NSF team to investigate, and we looked primarily at wind damage, but of course there was a lot of coastal surge damage, and so we looked at that. That wasn't part of our specific study, but of course we, being engineers and understanding hazards, investigated that over the course of the 4-day trip. And after that, I teamed with a colleague at Oregon State University. It wasn't Dan who's at Oregon State, but a colleague of his, Rakesh Gupta, and we wrote a proposal to the National Science Foundation to do 1/6 scale models and test wood frame buildings. And the difference was, this was the first time that I'm aware of in tsunami and hurricane testing where there was it was a damageable specimen. In other words, the waves were going to break it at some point or damage it. And the scaling of wood is very difficult, even at 1/6 scale, which seems large for these tests. But in doing that, then I wound up, I knew Dan, but just through American Society of Civil Engineers, other things. But then when he was the PI at the wave basin at Oregon State University, and so that's when I met him. And everybody loved watching the specimen be destroyed, and it was pushed out on YouTube, and I had comments sometimes that said, hey, that's not a real building. Well, yeah, it's 1/6 scale. We knew that. And so then Dan and I, shortly after, then there was Superstorm Sandy, but about 3 weweeks before that, we submitted a proposal to look at elevated coastal structures, and then Superstorm Sandy hit and destroyed elevated coastal structures. You may remember, New Jersey, things like that. And so the project, the impetus, the motivation for the project was there. Presumably the quality was there, so it was funded. And then Dan and I springboarded that work after a couple of years and wrote a proposal to the Coastal Resilience Center. And so we were brought into that mix and have been collaborating on that work for about 9 years, and have produced just a large number of journal papers, teamed with some of the stakeholders and end users in the federal government, and just thrilled to be part of that.
Seems to be a wonderful collaboration. We had Dr. Cox on the show a while back. Great conversation there, talking about that. Fantastic. So glad that you saw that episode. I love talking to Dr. Cox. He's a great guy, and you two make a wonderful pair. Because Dan Cox, he's got the Hinsdale Wave Research Lab, and there's definitely some entertainment value watching those buildings and stuff get destroyed by the simulated waves. But Dr. Van Lent, you are more of a field guy. You go out into the field, into places like Miyuki, Japan, and California, and you really get your hands dirty. And that is one of the reasons why you got featured on primetime television. What can you tell us about the Nova show on PBS?
So over the course of years, that one, we done a few others, and that was I'd say probably the biggest difficulty for that is that you find out that you're a professor and not an actor. I was extremely impressed by the way the production and what they go through. I think you watch this and you don't realize how much footage they shoot just to get a couple minutes, and it was fascinating. But that was I think watching that with the intro and then pulling historical footage for the motivation and things like that. I actually learned a lot just watching I think it was like an 8-minute portion of it or something, if memory serves, and learned a lot watching that, and that was a great experience. I mean, and I was I think for something like that, we really don't push out necessarily even a press release. They actually somehow hear about it and then approached us long in advance to set it up, and so I enjoyed it, and would do it again. Even though I think I had to get up at 4 a.m., but I would do it again.
See, you're somebody when PBS is coming to you for advice on this stuff. I want to really highlight that point. There are a few people in this field that know as much about structural integrity as you, and even the world, academic circles around the world know about you. You were considered a foreign expert in Japan before you even went over there. What can you tell us about the National Institute for Earth Science and Disaster Prevention?
Yeah, so NIED at the many years ago, I think they've since morphed their name into bringing in the term resilience and things. If I remember correctly, a few years ago, they're very, very large, very broad. They ran the shake table itself, so they had oversight over it, but they also have other facilities as well. They have I believe they have like an underwater shake table that works at scale for tsunamis and undersea earthquakes and landslides. And they have, I think that's at the Port Authority, and they have many facilities. So they're broad. They have supercomputer facilities, things like that. And so the collaborators. So we worked with professors, but we also worked with researchers that were generally would have a PhD, but they were with NIED or they were with the Building Research Institute, BRI, and some of them earlier in their careers, and now some are professors, some are still there, and so it was again some of the best people that I've collaborated with were part of that, and so but NIED is very broad. It's a research organization, but they also fund research. In the U.S., we tend to be one or the other. I think it's NIST and DHS and things do both, but not so much research for DHS, but they fund it, whereas NIST does research and funds research, whereas the National Science Foundation is just a funding organization primarily. And so we don't really have that exact, maybe our government labs like Argonne and again, this would be considered a government. They have labs within this. So maybe Argonne and NREL and things like that might be similar.
You bring up some interesting things here. And I was going to ask, because you've spent so much time in Japan and overseas, seeing how they deal with things, what was it like being over there doing experiments versus over here? Is there any big difference or similarities? What's it like?
Yeah. So if it's okay, I'll answer that on the professional side and then even the personal side, because it's kind of an interesting one.
Please do.
So professionally, it's very different. I mean, they generally will hire contractors, at least at the earthquake facilities, to do everything. And we're used to, when we were over there, you're always short on money on these massive projects. They're millions of dollars. You start with, it might be $3 million. You start with maybe one if you're lucky. And then as the momentum builds with the project, and you start to pique people's interest, then you start to get contributors and collaborators. And so there's always a chance. I think I've gave a talk one time to some young researchers and said, yeah, you sort of back yourself into a corner and then fight your way out and find money. And that's the nature of these massive projects. But in Japan, they use the contractors. And so, when we were there, perhaps much to their surprise, we after a while, the carpenters were falling behind timeline and we have to stay on time there. And so several of us, dropped left our computer behind, took off our sports jacket and grabbed a nail gun and went ahead and helped with construction and I've done that on most of the projects in the U.S. over the time in my own lab here at Colorado State University. And so we're used to it. So that was a little bit different. And then on a personal side, I would say, we to save money, we lived in almost like a dormitory about 3 miles from the site, and then we borrowed bicycles and we would ride on a bike path every morning and come back, every evening after the workday, working, sometimes 7 days a week. And I think we worked probably on that test, I believe 41 days in a row, and then finally realized we better take a break or we would break. And, but I think that's what it takes to get these projects done. And so, and for the most part, though, it's sort of that bike riding back and forth, the adjustment of diet, it's sort of like a purifying experience. So personally, it was enjoyable.
This brings to mind the split between theory and practice. It's one thing to talk about theory, but practice, that's another thing. You've got both sides of this equation here. You not only conceptualize, but you're putting in work on the line down there with everybody else. And that is pretty cool. You're invested in this. It's blood, sweat, and tears. And I think that's why the payoff here was so big. Talking about disasters in Japan, they, of course, had that really big earthquake back in 2005. They, of course, built back. But as you know, the hot topic of the day in the resilient space, it's buyouts and managed retreat. I want to drop the name of someone that you might know very well, Dr. Miyuki Hino. What can you tell us about Miyuki Hino?
Yeah, so Miyuki, I actually met her just several years ago. She's at the UNC Chapel Hill and is world renowned for her work in social equity and consideration of social equity in things like buyouts and focus on flood. I'm sure she does other things, but that's where I know her space from. And so we've been collaborating on a project. We've been looking at Lumberton, North Carolina, which had we did a large field study related to Lumberton over the years. And so this was ideal because we had a numerical model set up of Lumberton and literally, each building, synthetic population, synthetic household allocation to put in, families of certain income and race, ethnicity into each residential building. And so right now, in fact, just this morning, I exchanged emails with my graduate student working on that, and she's working on determining different approaches to socially equitable buyouts, based on income or based on race, ethnicity. But also based on where the hazard will most affect them. So who's most at risk, both from the hazard itself, but also considering that social equity. And we pulled in that's a collaboration with Miyuki, her colleague Todd Bendor, also at UNC, and then with Dan Cox as well that we just talked about. And that's ongoing. We hope to contribute to year 10 and extend that.
Absolutely. I love the Lumberton connection. And I want to set the stage for our listeners here regarding Lumberton. We're going to go back to October 2016. And at that time, there's a storm brewing off the coast of Colombia, a big one of the biggest ever. I'm talking about Hurricane Matthew. It slams into the Carolina coast after a state of emergency was declared. It caused widespread flooding, one of the worst we've ever seen. Doctor, what were you up to October 2016? And also, what's your outlook for Lumberton based on all the things you've seen and done for that area?
Yeah, so as part of a center that I run, funded by NIST, the National Institute of Standards and Technology, we had been interested in waiting to conduct a field study, and the field study was going to be a little different than just looking at damage. We were planning to go back each year or every 6 months. We didn't know yet to wherever this was going to be, and track recovery. But we would track not just the physical recovery, but the recovery of the economy, the recovery of the social institutions, schools, other things, as well as the recovery of the households. And so the idea behind this was really that, as Hurricane Matthew approached, I remember, sitting right here being on a Zoom call and discussing, saying, okay, it looks like this is coming in. We need to select a community to, based, and then, a series of calls over the course of several days as it approached. I don't think we knew it was going to be that bad. We thought that, we knew there would be flooding, but, because it's and that much was quite clear just from history and the amount of rainfall that was predicted. But I don't think we realized that the water was actually going to come around the levee in Lumberton and flood that many houses. And so once that occurred, we selected Lumberton, and then we go through, we contact, of course, they're busy. We wait a period of time to make sure that the water's receded. People are safe. We're not emergency responders, so we're not involved in that. But
right.
But we look more at the long-term recovery, the short-term effects, long-term recovery. And so this was really one of the first, if not the first, I would say the probably first field study that truly brought together social scientists and engineers. And so what we did is we brought the teams together. We developed protocols. They're all posted on Design Safe CI now, for the world to use or modify if they want to try and use it. And the idea was we did damage inspection, and then we interviewed households as well. And so the damage inspection, of course, by then, we went, I think 3 or 4 weeks later. So they were back in their homes, some of them, some weren't. And the idea was that we would take there was at least one social scientist and one engineer, sometimes a student, but on each team. And then we had our damage inspection household interview teams combined. And so they went out, and this really sets the initial conditions to develop this longitudinal predictive model for recovery. And so we're validating that, and that's our INCORE model, which is what was developed as part of the NIST Resilience Center. And so we're using that INCORE model on the Coastal Resilience Center project in year 9 and hopefully year 10 as well.
Ooh, now do our listeners a favor. Tell us a little bit more about the INCORE model. What is it doing that hasn't been done before, and why is it so effective at what it does?
Yeah, it's a great question, Bruce. So in the INCORE model, it's the Interdependent Network Community Resilience Modeling Environment. And so INCORE is it has all sorts of services, so web services, data services, all of these, and it's open source. And so the key is it's open source. So it's posted on GitHub. Anybody can use it, can download it. And so it's for the world to use. And it's being used in a number of countries, mostly by researchers at this point. And it is, so what it does is it models the physical infrastructure, it models all of the buildings. And I think we look at flood, we look at hurricane, we look at tornadoes, we can look at straight line winds, and then we look at earthquake as well as tsunami. And then we're in the process of putting in wildfire and some other things, and even heat, believe it or not. That's a complicated one. And so it models this physical infrastructure, but then it also models the households. We basically pull the census data for a community. We do this at the community scale, and that's because a regional scale is great, but the community is where the decisions are actually made. That's where often bonds are passed to make a decision. Build new schools, do things, and so it's really that's disasters recovery's local is basically the old expression. And so we have these synthetic population allocation algorithms that go into the households. We can populate the schools, all of these. And then we have data. We know, essentially not the actual person or the household, but we know within a census block, which is pretty small, where people live, where they work. So we can model the transportation flow, things like that. And then, so we model the hazard strike, which in this case, it would be the flood from Matthew. And then we can start modeling the recovery. And the recovery, of course, is a function of many, many things. It's not just physical. It's, for example, some of the models, it's, based on, say, a particular state where how often people are able to get certain types of insurance payouts versus not getting them, and all those things affected. And of course, baseline income. And so these are all the social science models led by we have a team of social scientists, a team of economists, and then a large team of engineers that have modeled this across 13 universities for the last 9 years.
This social science modeling, it seems like this is where the magic happens, because it's easy enough to predict what the weather might do. It's easy enough to predict how inundated the coast might get regarding floods and rising sea levels. But the ethereal factors of recovery, like you said, economic, social, all these things. How do you decide what to dial in on? How do you decide what to track? It seems like that is the billion-dollar question right now.
Yeah, that's again a great question. Within the center, we look at 4 areas of community stability, and one of them is population stability. And so historically, it's been shown that if a community after an event can keep the population intact and keep people from out migrating, such as happened after Hurricane Katrina, there was a lot of out migration because the buildings weren't inhabitable. And so if there had been somewhere for them to stay, safely, and the economics would have worked out. But that's really the idea, is to keep the population intact as long as it's appropriate. And so if you can do things to harden or mitigate potential hazards from affecting buildings and other infrastructure to a certain point. That's really the simplest approach. And then you can reduce the damage to a building, or you can. But the other option is how do you improve the speed of recovery even at the individual facility? Because for buildings in particular, it's probably buildings are what we would say is it's a necessary but not a sufficient condition for community resilience. And so we need it, but it alone cannot do it. We still need the services for, an example is dialysis centers. If people have to drive 3 hours and they have to do that 2-3 times a week, they're probably, may not be possible. They may not be able to hold their job, or they may need to move to the city where the dialysis center is. It could be something that simple. I mean, that's just one thread example. So there's and then we have physical services stability, social services stability, and economic stability. And of course, economic stability is key. The economy, safety is first, but the economy drives much of the decision making as well.
And it makes sense because these factors are essentially fundamental. They don't just apply to developed countries, but also developing countries. And you actually wrote an article very recently for the Conversation news outlet about 3 earthquakes that really, really rocked Afghanistan recently. This in-court project can apply to countries like Afghanistan just as readily as a country like the United States or New Zealand. Is that right?
It absolutely can. There's definitely challenges in the sense in the data is the challenge. And for example, we have the U.S. Army Corps of Engineers developed the National Structure Inventory, which is ideal. It's really all the buildings. We have Department of Homeland Security has all of the basics for the infrastructure. It doesn't drill down into so much detail that it gets anybody in trouble, but it's enough level of detail to be able to do an analysis in a lot of cases. And a lot of countries don't have that. A lot of developing countries, really most. Some countries do, some mainly the large countries that are producing technologies do have that, China, South Korea, of course, Japan, and a number of others do have excellent data sets. But somewhere like Afghanistan wouldn't. But that's something that we're starting to work on right now. We're looking for philanthropic support actually to try to produce some examples for developing countries. We had a lot of questions from colleagues in Nepal because of the events there.
Wow. So it's not just focusing on equity in the United States. This is a global initiative here, trying to have a rising tide to lift all boats.
Yeah, that ideally, I mean, I think we would all, the huge team involved would love for it to be, and we're in the process. We've just started essentially a equivalent of a nonprofit called Project Encore out of Oakland, California, and they're, I just was on a call related to that before having this great interview with you, and the idea is to help communities. We're going to be helping a lot of the new Cedars communities.
I want to talk about Oakland. I do. But before we get into that, I want to get back to something a bit more global. And again, talking about Miyuki Hino and your work with her, we can't talk about Miyuki without mentioning another major player in this realm. And I believe you've drifted into his world more than a few times. Tell us, what were you doing in Christchurch, New Zealand in 2011? And did you bump into Gavin Smith out there?
Great question. So New Zealand, Christchurch, New Zealand. Interestingly, so I was in Macedonia at the European Conference on Earthquake Engineering, and I was sitting having a cup of coffee with about 4 professors from University of Canterbury in Christchurch, and this was in 2010. And all of a sudden, everybody's phone started buzzing, our smartphone started buzzing, and it said, "Oh, Christchurch just got hit by an earthquake." And so within about an hour, they're booking their flights to get back. And so that was their first earthquake. And that one was about 30 kilometers from the city. It was a little bit deeper, maybe 30 or 40 kilometers from the city. And so it damaged some buildings, but there were no deaths, if I recall. And so it was sort of a wake up. But then about 4 or 5 months later in 2011, I think it was 4 or 5 months, there was an earthquake that was maybe only 8 or 9 kilometers from the city. And it was the magnitude of the earthquake was slightly smaller, but it was so close that it completely devastated Christchurch. And buildings were, and for those that don't know, New Zealand has a long history with earthquakes. They're, some of the world's best earthquake engineers are on the faculty of these universities, University of Auckland, University of Canterbury, and Christchurch. And so this was very surprising because a lot of their work has gone into building codes and things. And so I think they were equally as surprised. So they wound up having to tear down just a huge percentage of Christchurch because they felt like these buildings just weren't going to perform if it happened again. And some of them were damaged beyond reasonable repair. And in fact, the hotel I stayed at my first time there in 2003 had to be torn down. And I remember in 2003 walking out, and the whole bottom floor of it was glass. And I remember thinking, well, where's the earthquake part? But that was maybe not the best design. And so when I was there, I was with a team. We were looking at, and so we on that trip, I actually didn't get to see Gavin, but we talked about it quite a bit over the years. And so, and I think we were on the wood frame team, so we were actually separated from the business district, and so we were actually off more in the liquefaction area where the just an extensive amount of damage. But I know there's a bunch of teams went down there and did really good work.
What was it like? What was it like to experience that? You had colleagues that were going immediately back down to New Zealand. How did it affect the community that you were in at that time?
At that immediate moment, you don't really realize the severity. And of course, with that first one, now the second one, we knew pretty quick. There were videos from cameras, on sky cams or whatever they call them, and there were videos of just the shake, in the distance, and then just this rising dust from collapsed buildings and things. And so it was quite clear that when you see that, it's quite clear that there's something very, very wrong. And so within an hour, I think the world knew that there was trouble in the 2011 event. And so people, began the process of mobilizing, ASCE, all of the, probably, I'm not positive, but probably AISC, ACI, all the concrete and steel, all these organizations, as well as a number of, groups writing proposals to the National Science Foundation to go down there and learn. And then EERI went down on a big study. They have a Learning from Earthquakes program and sent a group.
Now, it must be very bittersweet to be in your position because you are the world's foremost expert on structural integrity. To see this major collapse in a country and then to watch them build back, do you think they're building back better based on what we know now?
Yeah, that's a great question. That's probably the part I left out. So is that they're really... once this occurred, they realized, okay, this is not tenable. It's not acceptable, for a ultra modern society that has earthquake engineers. And so they said, okay, we want to make sure, can't control Mother Nature. Let's control what we can control, and that's the built environment. And so they started to look more at resilient construction. It's really, we called it for many years, it's performance-based seismic design, well-performing buildings, buildings that perform above and beyond code. They also change building codes, things like that. And so, and the goal is, keep keep those buildings not only safe, but keep them operational after an earthquake. In fact, there's a big effort right now that focused on functional recovery. And so the NIST, the National Institute of Standards and Technology, they just about 3 years ago, maybe, and probably 2 years ago, held a workshop in Washington, D.C. And this was asked by Congress. They were asked, I guess, to develop a report that said, okay, this is what we need to do to get to functional recovery of buildings for design. And so they're focused on that. And so NIST just recently, they knew we were testing a 6-story building. They asked us to install fire sprinklers. So we just tested those last week in that 6-story building. And so it's 2 floors of fire sprinklers, the riser going all the way to the roof, and 70 channels of instrumentation, and that's really focused on their effort for functional recovery. In other words, you can't be in a commercial building without fire sprinklers intact.
Very true. You mentioned NIST reports and functional recovery. You've jogged my memory. I've been dying to ask you, because you are, of course, a NIST Center of Excellence co-director. And the last time NIST was really in the headlines and in the sphere of public consciousness is when the report on 9/11 dropped. Obviously, planes hitting buildings, way different than waves or earthquakes going after buildings. Or is it? Does your work dovetail into terrorism?
I wouldn't say it dovetails into something like that. I think anytime you have, because what we deal with is natural hazards in the center, and that's because we, historically we can predict the risk level, or not the risk level, but the probability of occurrence of an event, and that's because the hazards themselves are non-intelligent actors, and so that allows us to be able to assume that it's not that there's nothing behind it, and so we don't really deal with that. Now, that being said, people have written papers on, okay, if I designed this building on paper for a much stronger earthquake, would it do better? Things like that, and so presumably stronger buildings would do better in those, but we don't focus at all on that mainly for that reason, and just not knowing what the actual risk is, and of course, we don't focus even on all natural hazards because even though the center was very well funded for the last 9 years, with our 10th and final year starting next week, it's you still have to, you can't be all things to all people to all. You have to decide what it is, and I'm a firm believer in picking one or several things and doing them really good, rather than sort of just spreading out and doing everything topically.
Very true. Specialization is key, and you're right. You cannot do all things for all people. And in the realm of flooding and earthquakes, you've done very, very well. And talking about floods, actually, I want to set the stage for our listeners here once again and talk about something that happened that you were heavily involved in. It's June 2008, and the heavens have been wide open for months over Kansas and the rest of the Midwest. It's almost biblical. Levees are breaking, dams are failing, rain, it just keeps coming. And the National Guard gets mobilized to pull people trapped in houses now underwater. It's really bad out there. Dr. Van Lindt, where were you in June 2008, and what were you about to do for FEMA?
Yeah, so interesting. So I had a student, a graduate student, early in my career here, and in the early 2000s, and we had worked on developing flood fragilities, and they were really the first flood fragilities to be developed, because FEMA's HAZUS uses depth of damage functions, which are deterministic, but we had looked at it more in a probabilistic sense, and he had gone through the literature and then pulled this in, developed a numerical model, and so we pushed these out into the academic literature, and so FEMA picked up on that contacted me and said, "Hey, would you be interested in joining our mitigation assessment team study?" And so FEMA, after big events, they decide whether they want to mobilize and on these, and so the concept of the mitigation assessment team for FEMA is that they, when they do buyouts, like we talked about a little while ago, when they do buyouts or when they put in for tornadoes, they put in safe rooms or tornado shelters with give a community or a individual building a grant, or they're buying out residential properties that are in the floodplain, turning them into parks or things like that. And when they do that, they want to see if it worked. And so the mitigation assessment team, they send a team out. They actually send a pre-mat out, which is usually like 2 or 3 people, just to make sure it's worth doing. So they had sent out a group, usually contracted through usually contractors, and then some colleagues from FEMA as well. And then they bring in other experts. And so I was asked to go. So I went out for, can't remember exactly how long. It felt long, but I think it was 10 days, 10 or 11 days. And then we went around. We primarily focused on Iowa and Wisconsin. And like you said, I mean, the flooding was just it was staggering. It had actually reversed the flow of a river in the Wisconsin Dells, and just from the, and whole communities just. And a lot of these had basements, so the basement filled up, and there was even more water, and so just these huge plains floods that covered massive area. It takes a lot of water to do that, like we know from watching the news and other things, and so the idea was so we basically go in. We have all of the coordinates on these buyouts and other mitigation options, and we take a look. We also we went into, that was the first time Cedar Rapids, Iowa was. They had been flooded before, of course, but that was a devastating flood for Cedar Rapids, and they since that time had done some great mitigation. So they've put in some really, they're, I would say, resilient now, at least, as long as climate doesn't keep changing and things get worse and worse.
Right. I was curious, did your recommendations produce a safer region down the line? That's the big question.
Yeah, for the most part, the buyouts do work. I mean, we see that the places that were bought out, do flood, and they continue to flood, but the playground equipment in a park, the park benches, things like that are okay. They dry out, and the kids go on to play on them. So it works fairly. So the process works fairly well. I think brings us sort of back almost full circle to are the buyouts socially equitable? Well, that's an open question, and that's why we're still doing research on it with Miyuki and others.
And I guess the really big question too is, when do you stop trying to just manage the hazards and just do the buyouts? Because obviously there's managed retreat and there's mitigation. And, when do you stop mitigating? When do you just say, okay, this is too much? For example, New Orleans, it's a great example. Where do you draw the line?
Yeah. And I think that's, it's well asked, Bruce, because it's really a line. It's sort of this large gray area, and we attempt to sort of shrink it to a line sometimes, but at some point, I think everything requires a discussion with the community, and not even just the community leaders, but with the community, and that's where the social science aspects, the community planners, urban or even just planners, if it's a rural area, are needed to have those discussions and find out. And you see that I just did a Zoom interview with a potential student from Indonesia, and he was talking about he's a structural engineer, wants to come back to school, get graduate degrees, and just this morning, and he was saying he wants to learn more because he wants to be part of them moving their capital city, which I'm sure you've heard about.
Certainly have. It's, at the end of the day, I suppose it's definitely all about community. And speaking of community, you actually talking about floods in the Midwest. you've got a personal connection to communities in the Midwest beyond FEMA. You got your master's and your PhD at Texas A&M. And I'd like to throw out two names that might be familiar to you, Billy Edge and Dick Seymour. Can you tell us anything about Billy Edge and Dick Seymour?
Yeah, I definitely can. So Billy Edge was on the faculty there for a number of years. I think he's moved now. I think he's back east now, but he collaborated with my advisor John Nitzwicki when I was in school there, and so I started my master's in 1995. My master's work for several years. For 1993, finished in 95, and I worked at the Offshore Technology Research Center. And so Dick Seymour was the director of the OTRC, which was a National Science Foundation funded engineering research center, so as a student, I didn't have day-to-day interaction, of course, with either of them, but then symposiums, things like that, I would have. And so Dick Seymour had also been a director at Scripps, which interestingly is right where the shake table is that I go to, and I'll be going Sunday again. So it sort of everything comes around. He's not there anymore, obviously, yeah, and so I've kept in touch with Billy through NHERI, which is the Natural Hazards Equipment Research Infrastructure Program. He's part of that effort for NSF, and then Dick I've lost touch with, but with Billy Edge, yeah, I'll probably see him in a few months in Washington D.C. at their next symposium. So yeah, that's a great memory.
Nice to hear you keep up with them. And our listeners may not be familiar with those names, but they are giants in this space. And
absolutely,
it takes a giant to make a giant. So major players in the coastal resilience space. But before even, this stuff, before all this, your beginnings actually were a bit further west. I want to go back to the year 1989, the date of the Loma Prieta earthquake. Tell us how the Loma Prieta earthquake influenced you and where you were at that time.
Yeah, so I was doing my undergraduate. Would have been in probably my second or third year at Cal State Sacramento. So I was about 70 miles from San Francisco. I remember the day of the Loma Prieta earthquake. Interestingly, I had actually started as a physics major for a couple of years, but then something kind of turned me to, when I was very young, I always wanted to be for some reason I'm not sure why, but wanted to be a defense attorney. And so I switched to criminal justice and started, doing case brief classes, things like that. So it's possible. It's possible that I was even in criminal justice when that earthquake hit, believe it or not. And so when the earthquake struck, I remember on the news. In fact, I just lectured. I'm teaching graduate level earthquake engineering. Just lectured yesterday and told them the story of Loma Prieta. Interestingly, that earthquake was the first earthquake, at least in the U.S., that if people that are older might remember, but the top story of a 2-story freeway overpass collapsed in San Francisco and that in the Bay Area at least, and that was the era of we weren't carrying around cell phones, but there were car phones, and so there were people calling from the collapsed structure for help. They were dialing 911. I think they did get to some. I don't remember the details, but how much impact that direct one had on me, remains to be seen. But I remember taking a statics course the next year, and then became a civil engineer. And 3 years later, was 2 or 3 years, can't remember exactly. Then decided, okay, I want to get a PhD in structural engineering, and then just went straight for it. So.
This is quite a revelation, Dr. Van Lin. You were thinking about law initially. Wow. And I suppose it's good that you didn't do law, because we are indebted to you for the work you've done the models and what you've developed have been used the world over to make everybody safer. So your path has been a righteous one indeed. And of course, you're at Colorado right now, the Harold H. Short Endowed Chair, Professor of Civil Engineering, very, very high honors. There's also a Deep South connection there. What can you tell us about the South Engineering Research Center at the University of Alabama?
Yeah, so back after spending the better part of the year off and on with a few long stays in Japan for the testing there, came back and a colleague at the University of Alabama in Tuscaloosa was a longtime friend through committees on wood and things like that at the national level. And he contacted me and, asked me to come give a seminar there on the shake table testing in Japan. So I did. I think that was would have been maybe sometime early first half of 2010. And essentially when I arrived, he said, oh, and by the way, we have an endowed chair that's become available position, just so you know. But anyway, can you give your seminar now? And so I gave the seminar, and and then we talked a little bit, and he said, well, do you have any interest? And and I had I think had the opportunity. They had their laboratory there. Had the opportunity to, it was they hadn't even poured the foundation yet. They just had the size of the lab, and they had said, okay, we want to build an earthquake shake table, and it would be fairly large. And so I had the opportunity to really shape that if I was to go there. So I, talked to the family. The kids were young, so it was my wife, and convinced her that it would be a good opportunity. So we moved down. We spent only a couple of years. I think, deep down, I'm a Coloradan at heart, it feels like. So after a couple of years, we had an opportunity, I didn't, of course, keep anything here. So an opportunity to come back to Colorado State University was there. And I interviewed for it and had to go through the whole process, and came back for a professorship, which then and then moved into an endowed professor, as you mentioned. So, but it was a good experience, and then perhaps I had the opportunity to interview a bunch of faculty for 3 positions there, and then after I left, they wound up hiring one of my postdocs who does similar work, obviously, because he was my postdoc. And so now he's on the faculty there, and in fact, collaborates with me on some of these field studies. The last 2 years have just been out in the Midwest looking at tornadoes and things like that.
Ooh, and speaking of tornadoes, you actually gave a TED Talk and talked about tornadoes a lot. How was that experience?
Yeah. I think all of the tornado work, I guess it kind of comes again, almost a little circle there is that the reason I do tornado work is I lived in Tuscaloosa when the 2011 Tuscaloosa tornado hit, but and then I moved back here and a flood hit. So, I've gotten the jokes, but but when I was there, I actually wasn't in town. I was actually back here at Colorado State because I had just moved about 6 months earlier, and we were finishing some testing in the lab here that we had started. And so I remember when tornadoes and weather hit, sometimes with the various power lines and cell phone towers, it's often hard to make calls into the area. It's often hard to get calls out, but calls can sometimes get in, and then texting is easier. And so I was basically on a laptop looking at the weather to see where the tornado was hitting exactly, and texting my wife. And unfortunately, there's not basements in Alabama in general, and so we didn't have one either. And so they were, in a closet under the stairs waiting for it to pass. And it went 2 miles from our house, so we weren't impacted directly. But but then went back and we did an NSF funded field study on the tornado with colleagues, with Dave Pravat at Florida, who's, longtime collaborator in that space, and as well as some others that now are part of NAHARI, and many are professors themselves. So it's sort of, it's always nice that these produce, but I've always loved giving a talk that's sort of focused, and I gave one on NAHARI and earthquake engineering, I think at the National Academies building in DC, and that was a really good experience. I think I'd say the hardest part for me is that you time the slides, and so you can't tell a story, which is sort of what I even do that in class. I tell stories sometimes.
This is how we connect with stories. It's very, very true. And speaking of stories, I mean, you mentioned DC. There's so many of your projects, so many roads that run through DC, that run through your projects that go to DC. I mean, the Department of Commerce sponsored you. DHS is backing you now. There's lots of splashing in your projects too, but I understand a place in DC might have splashed you once. Can you tell us anything about the old Ebbit Grill in DC?
Ebbit Grill, oh god, well, good. Yeah, I almost forgot that one. Yeah, I think that was the DHS dinner after we had a meeting all day for the Coastal Resilience Center, and I remember, I think everybody had, was probably by 7:00 by then. Everybody had ordered their drinks, and like a good grill in DC. We were waiting for the food, and they had these very tall, maybe 20, 18 or 20 ounce beer glasses, and I remember the waiter coming over, and he was holding it right over me, the whole tray, serving people, and I remember getting nervous. And then, sure enough, it went. And so, yeah, I was a little more than splashed.
A lot of potential energy there, but they paid for your outfit, didn't they?
Yeah, I think they, if I recall, they grabbed me. The pants were fine, but if I recall, they grabbed me a shirt because I had only come in for one night, and I was flying in, and I was supposed to go to I think I was supposed to go to the DHS, one of the DHS meetings. I think it might have been the kickoff meeting and so we were going to see, colleagues we hadn't met, and no chance to do laundry, and didn't want to smell like an IPA. So
right. Well, at least they did right. At least they did right by.
Yeah, they were very nice. It's fantastic food too. Once I was dry.
Well, let it be known, Dr. Vanderlint, cool under pressure. He might get splashed, but he's going to come back, and everything's going to be fine. No issues there. It's a testament to your mettle and your character as well. And I mean, that's really why you're the co-director of the NIST Interventions. I mean, you've been asked to speak all over the world, and winding down here, I want to talk about your legacy here. I mean, thanks to people like Dan Cox and your colleagues and what you've done, our buildings don't collapse when things get rough. People take it for granted, but that is the truth. You are the unknown, the unsung hero that keeps us safe in that regard. And with that in mind, what are your biggest recommendations when it comes to building stuff, and what's your outlook moving forward here?
Yeah, that's I would say the biggest recommendation, and this comes from working for coming on 14 years or so in the resilience space, that I'd say the biggest recommendation would be, to ensure a resilient community is pulling everybody in to the same table, figuratively, and so that includes the different disciplines, and we're seeing that a lot more, but also the key players. So in other words, the privately owned facilities, the publicly owned entities, the public government buildings, private buildings, and getting them all on board to achieve a certain level, and then not pointing blame when when there is a weak link in the chain, but rather than pointing blame and blaming, just working to fix it, realizing that it is a chain.
Very much so. It takes a village. And I think everybody that I've had on the show has echoed that sentiment. It really takes a village. This is a communal effort, and we all get through this together. And as long as we keep that at the forefront of our minds while working on individual projects, it's going to be much harder for us to fail. Oh, this has been such a wonderful interview, Dr. Vanderlyn. Let us know what you have going on right now. And if there's anything that you want to tell the people out there, this is your opportunity. The floor is yours.
Yeah, I guess I'd say the biggest thing right now is it's really not even a research project, but it's we have those going, of course, as well. But it's really Project Encore. I mentioned it briefly earlier, but and helping communities that are designated as community disaster resilience zones by the Act of 2022 of the same name. And that was an act in 2022 was passed, almost unanimously in a bipartisan way. And the idea is that it really is, these are the 1% or even less in some cases of communities, say most at risk communities, and they're at risk because of a hazard, often flood, because a lot of the focus is on climate, but it looks at all hazards. But then also it accounts for incomes and accounts for, basically the social vulnerability as well. And so it combines those to look at really, who in the US, which communities at a census tract level, and that's usually like 4,000 to 6,000 buildings, or people rather, need help first. And so are most vulnerable. And so if you help the most vulnerable, then you make the US a better place. And so that's what we're working to do with Project Encore.
Love that, Dr. Vanderlyn. Help the most vulnerable. It makes our country and even the world a better place. That's something we can all get behind. I just want to thank you so much for being on the show. It's been such a great experience, and we appreciate you.
Well, thanks, Bruce. And likewise, this has been fantastic. Maybe the if not certainly one of the most enjoyable interviews I've had. So thank you.
Thank you so much. I appreciate that, Doctor. I do my best. Looking forward to seeing you at the annual meeting coming up later on this year. But until then, to our dear listeners, check out our website, coastalresilienccenter.org, and look at all of our Twitter and social feeds through Linktree. That's Linktree/Coastal Resilience. Thank you so much for tuning in. It goes without saying, but we are always, always, always so very thrilled to be seeing you shoreside. Hope you stay warm out there. Hope you have a tremendous Valentine's Day. CRC loves you. We can't wait to see you again. Bruce Rosenblum signing out from Shoreside. We'll see you real soon.